Welcome back. We're going to wrap up our lesson on probability here by talking about a situation with blood types. Now, according to the American Red Cross, the distribution of blood types in the U.S. population is 45% have type O, 40% have type A, 11 have type B, and 4% have type AB. So what we're going to be looking at here is we're going to be pulling out groups of two people and finding the probabilities that their blood types match different configurations. We're going to use this problem to talk about the way that we construct problems in probability. So here we go. If two people are chosen at random, find the probability that both have type O. So if you think about this, kind of using those constructs that we've been working with, we have two things going on here. And both of them have to be type O. So event 1 and event 2. And so this is going to be an and situation. And we're going to talk about this in just a minute. Like, what is the difference? Like, why am I talking about and versus, in a minute, we're going to talk about or. But we're talking about an and situation. Like 1 and 2, they both have to be type O. So both is this and situation. And so what we're going to do is, this is going to be a multiplication situation, because to find this probability right here, we're going to have that 45% that have type O. Well, the first person has a 0.45 chance, so 45%, 0.45 chance of being type O. And because both have to happen at the same time, it's an and situation, and is multiply. And so the probability of O and O is equal to 0.45 times 0.45. And when we do that math, we get 0.2025 or 20.25%, okay? B says neither have type A, which means that if we consider this thing as two events again, okay, so this is not A, and this is not A. Well, sometimes when we're dealing with probability, instead of thinking about what it possibly could be, because it's not A, it could be B, it could be AB, it could be O, it could be O negative, down the line. It's easier to think about it in terms of what is A? Everything else is not A. Okay, so if A is equal to 40%, okay, type A is 40%, then not A is everything else, which is 60%. So instead of trying to add up all these things and take into, did we think of everything? Just think of not A as everything that's not A. So it works. So it's 60%. And so because this is neither, we're going to say both of them don't have type A. So this is another multiplication situation. So we got 0.6 times 0.6, which is going to give us 0.36. So there's a 36% chance that neither have type A. Okay, take that for what you will. What about both having the same blood type? Okay, so up here we had both. And so this is another and situation. So person 1 and person 2 have the same blood type. So that's going to be multiply. But what are we thinking about here? And you kind of have to think about the possibilities. So the first possibility is that person 1 and person 2 could have type O. So O and O, which would be, like we discussed above, 0.45 times 0.45. But the problem is, it can't just be type O. It could also be type A, which would be 0.4 times 0.4. But it could also be 0.11 times 0.11, and it could also be 0.04, which is this type AB, times 0.04. So how do we know what we're looking at? Well, I have to consider all of these things because all of them are valid possibilities. So the possibility that exists that it could be OO. Well, when I do OO, I've got 0.2025. So there's a 20.25% chance that it's OO. But it also could be AA, which was that 0.16, because when I multiply 0.4 times 0.4, I get 0.16. And I could also have 0.11 times 0.11, which is 0.0121. It could be that also. Or it could be 0.04 times 0.04, which is 0.0016, which would be really rare because that would be less than a 1% chance. But because it could be any of these, we're going to use an or. Okay? And or means add. And so I'm going to add all of these probabilities up because it could be this or this or this or this. So this or this or this or this. And I have to add those together because any of those situations fall into the same category. So when I add these, I'm going to get 37.3762, which is 37.62%. Okay? And so and is going to be multiplied. So both multiply right here. Both have the same blood type. So that was multiplied. But we had to consider the fact that it could be one of four things. So it could be this or this or this or this. Okay, which brings us to the addition property of probability, which says this. If it's the probability of A or B, we're going to add the probability of A plus the probability of B, but we're going to subtract the probability of A and B. So events that overlap. So for that, the blood type example isn't a great example to illustrate this because we don't have anything that overlaps. But if we had something that overlapped, for example, this next one we're going to do has some overlapping. We're going to talk about mutually exclusive events. Mutually exclusive events are events that can't happen at the same time. They don't. A and B don't occur at the same time. Okay, so they're non-intersecting events. So let's look at an example that involves both of these types of principles. So at Pascal High School, 68% of the students have cell phones, probably a little low for this day and age. 77% have iPods, 62 have both a cell phone and an iPod. What's the probability that a student has a cell phone or an iPod? Okay, so immediately we should be thinking, oh, I'm going to add here. Okay, so I'm going to add. So the probability of cell phone plus the probability of an iPod. So let's look at what we're thinking about here. If I'm looking at probability of cell phone and the probability of an iPod, we're looking at 0.68 plus 0.77. And we're in trouble because what does that mean? Well, that would mean we have more than 100% of the kids represented. But we have to subtract the fact that some people have both of them. So 62% of them have both a cell phone and an iPod. So we have to subtract 0.62. When we do that, we get 0.83, which is 83%. Think about that for a second. You know, if you took 62%, so we know it's at least 62% because those people have both. But one kid holding a cell phone and an iPod can't count in both categories. But then we have to consider the fact that, well, how many people have just iPods? And actually, you know, if we did a little bit of a Venn diagram here, in the middle we have that 62%. Well, if you think about it, in this circle, the whole circle, if this is cell phones and this is iPod, this whole circle for cell phones is 68%. Well, 62% of them are sitting right here, then this is going to actually just be 6% here, right? And if I'm thinking about iPods, and I know this whole circle represents 77%, then this is 15% here. Well, what does that mean? Well, they share 62%. So these people have a cell phone, but they also have an iPod. So the percent of people that own a cell phone, right here, 68%, both of those numbers. The percent of people that own an iPod is 62 plus 15, which is 77. But 62% of them just happen to own both. And so the sum of what we're actually talking about here is 6 plus 62 plus 15, which is 83% of everybody. But you take out that middle shared portion because you can't count those people twice. Which leads us into part B. Have a cell phone or an iPod, but not both. So when we look at cell phone or iPod, but not both, we're looking at cell phone and iPod, but not both. Okay, so it's one way to think of it would be to say if I've got 83% of the population that has, from up here, a cell phone or an iPod, I could subtract 62% because they have both, and I get 21%. Or I could say, well, here they are right here. If I drew a Venn diagram, I'd have 21% as well that didn't have that shared 62% in the middle. Okay? So when you look at these probability problems, just remember, and means multiply, and then or means add, but to subtract back the shared portion. Okay, guys? Thanks for watching, and we'll see you next time.